In this tutorial, we are building a lab report analyzer using AI. This is a very simple project, but the goal here is to inspire you. We want to show you the life-changing applications you can build using AI, and you can definitely improve on this project later. Here, we have the option to upload a lab report for analysis. Now, using Gemini AI, we are able to extract every single detail from the PDF into text. We then feed it back into another chain of prompts. This analyzes the report and interprets it for the patient. Patients or users can even add a follow-up question to the report generated by the AI. We also have an AI chatbot, which works similarly to the one in the lab report section, and we have notes. This allows the patient to keep a journal of their journey or anything else. We use Supabase for authentication and for storing the lab reports and notes. We use agent actions from Scalekit to send emails to the user after analyzing the lab report. You will also learn how to use Google OAuth and so many other tools. According to YouTube Analytics, most of you who watch my videos are not subscribed yet. Please consider subscribing and hitting the like button. I am excited to introduce my first software as a service project called I Built This. I Built This is built for developers who want to escape tutorial hell. Learning to code is just one piece of the puzzle. You need real projects with real teams. I Built This is about quality, hands-on projects. We have a couple of projects on the platform which have AI recommendations based on your interests and learning goals, which you inputted during onboarding. The projects are also categorized into different fields. We have web dev, mobile dev, AI and machine learning, and gaming. We have a couple of daily and weekly challenges you can have your hands on to practice and improve your coding skills. This project is one of the ones I built a couple of months ago, so I will click on it and build it with the help of I Built This. After joining the project, we set it up and then start building. On the task page, we can use AI to generate tasks, and if they're good, we assign them to ourselves. So I will assign a couple of tasks to myself and click on the Complete Setup button. Then we move to the project details page. On this page, we have the project progress, the tasks, and we can update the project settings, like the project timeline and other features. So let's add a new milestone to the project by clicking on the project settings button. On this modal, we add a title and due date for the timeline and save it. And we have it here. On the task page, we have all these statuses which you can drag to a different state based on the current task you're working on to keep track of your progress. Let's talk about challenges. On the challenges page, let's say I am interested in this challenge called longest substring without repeating characters, and choose to join this challenge using the Join Challenge button. Now upon joining, we are taken to the dashboard. On this dashboard, we can work on the challenge in real time with our inline code editor. If your code satisfies all the test cases, you can publish it for others to have a look or get inspired by your solution. Not only can you work on the coding challenges, but you can also work on the design challenges. These challenges give you access to code and allow you to see changes in real time. As you can see on the dashboard right now, you have the ability to toggle between the design you are building and what you have built so far. If you are satisfied with your solution, you hit the publish button and you are good to go. You can also save your code and continue later anytime you are ready. On the dashboard, we have the chat feature for projects that need more than 2 teams. Everyone gets the message, it broadcasts to everyone. On the project metrics section, we have your total projects, challenges, total activities, and contribution scores. This is a project that will genuinely change the way beginners and even professional software engineers enhance their skills. If this sounds amazing, kindly visit ibuildthis.com and start working on a project now. Follow us on socials, on Twitter, TikTok, and YouTube. Links are provided in the description. If you are a developer, designer, or founder, you know the specific kind of pain I'm talking about. You see an incredible design on Dribble or a smooth feature on a competitor's website, and you think, I want to build that. But then reality sets in. You have to open your IDE, set up your div structures, wrestle with CSS grid, debug mobile responsiveness, and spend 3 hours just getting the layout right before you even write a single line of actual logic. What if you could skip that entire first phase? What if you could just show an AI a picture of what you want, and it gave you production-ready code instantly? Today, we are taking a deep dive into Komposo AI. You might know it by its former name, Copycoder. It is an AI tool designed to turn any screenshot, mockup, or design into clean, editable code. But does it actually work? Is the code usable, or is it just a messy AI hallucination? Let's find out. Komposo isn't just a code generator. Think of it as a UI reverse engineering engine. The core promise is that the web is your template. You don't need to start with a blank canvas anymore. Whether you have a screenshot of an app you love, a sketch on a napkin, or a Figma file, this tool translates visual pixels into syntax. Let's try a real-world example right now. We are going to use a screenshot of a fairly complex SaaS dashboard. It's got a sidebar navigation, data cards with specific spacing, and a main content area. Usually, coding this layout from scratch with Tailwind CSS would take roughly 45 minutes to an hour just to get the responsiveness right. We are dragging this straight into the upload box. Okay, it's done processing. Look at this comparison. On the left is our static image. On the right is the live code. It didn't just guess the layout. It actually recognized the components. It identified the navigation hierarchy, the button styles, and even the subtle shadowing on the cards. It has effectively cloned the visual structure. But here is where Komposo separates itself from generic AI chatbots. This isn't just a static dump of code. It offers a workflow called Design with Prompts. You don't need to dig into the CSS file to change things yet. You can just talk to the design. We can tell it, make the header gradient blue to purple, or swap this section to the right side. It functions like a junior front-end developer who types incredibly fast and executes changes instantly. Now, for the technical viewers, I know exactly what you're asking. Is the code garbage? Let's look under the hood. You can export this to React, pure HTML, or even get optimized prompts for other AI assistants like Cursor or Claude. If you look at this structure, it's surprisingly clean. It uses modern practices. If you select Tailwind, the utility classes are applied logically. It's not spaghetti code, it's semantic. This means you can actually take this, drop it into your project, and start connecting your backend logic immediately. This enables a new workflow called the visual stack. You start in Komposo to get your UI and UX locked in visually. You export that code, paste it into an AI editor like Cursor, and then ask Cursor to wire up the backend. You are effectively cutting out 90% of the front-end grunt work. For solo founders, freelancers, or small teams, this is basically a speed cheat code. Komposo AI is the perfect tool if you hate staring at a blank screen. It won't build your database and it won't market your product, but it will get your interface to production quality in minutes rather than days. If you want to try it out, the link is in the description below. Go clone a site you love, tweak it to make it your own, and see how fast you can build. Thanks for watching. If you want more deep dives into AI tools that actually save you time, make sure to hit that subscribe button. This is going to be the starter file for this project. We are going to clone the app from my GitHub repository. When you click on the GitHub repo link in the description, you will find this exact project. Click on the clone button and select your preferred connection method. You can use HTTPS, SSH or the GitHub CLI. Once you are done, you should have the same file structure as mine. On the File Explorer, we have the app directory. We have components, hooks, lib, and the public folder. Inside the app directory, we have the layout file. This is going to contain the global layout for the application. We export the metadata here, which contains the title and description of the application. And then we have this export function right here. Let me explain what is happening in this code block. We export the default function named root layout. It accepts the children property as an argument. We define the type structure here as read-only, and inside that we specify that children must be a React node. Inside the function, we return the JSX structure. We start by opening the HTML tag and setting the language to English. Next, we open the body tag. Here, we apply the class names for our Geist sans and Geist mono variables, along with the anti-aliased utility. Inside the body, we wrap the children prop within our conditional layout component. Then we close the body tag, and finally, we close the HTML tag. Moving on, we have the page.tsx file. This is going to be the home page. When I run the command npm run dev in the terminal and navigate to localhost port 3002 in my browser, we get to see the dashboard page. This is going to be the central hub for the lab reports, the AI chatbot, and the pending notes. We have some dummy data set up here. We have data for recent lab reports, which includes an ID, a file name, and the upload date. We also have data for the news section, which has an ID, a title, and a created date. In the code structure, we have these headers and the text ready to go. I assume you have a firm understanding of CSS and styling, so I am not going to go through every line of styling code here. We have this array to loop through the statistics. This mocks fetching data from a database. Basically, we display the recent news, a new note section, and a button to add a new test. This displays the content of the test in this large pane that covers the home page. Next, let's look at the components directory. This contains our UI elements. We have the app sidebar file. This is responsible for the sidebar navigation. Specifically, we have the dashboard, the lab report, the AI chat, and the notes. We have the data for these menu items here. This includes the title, the icon, and the href, which directs the user to the correct route. We also handle the logo and the current year. Down here, we loop through the menu items to render the icon and title, ensuring they are clickable. That is the primary job of the sidebar. Now, if you go to the overview page, it lists all the lab reports. We have state variables to store these lab reports. We have handle functions, and we have methods to calculate the statistics. We will go into the details of this logic when we start writing the back-end code and integrating with Supabase. When we click on the Connect Email button, it shows a dialog. This dialog will be responsible for using Scalekit to send the lab result to the user's email after the AI generates the results. Everything else you see on the report page will be explained in detail later in this tutorial. The next thing we are going to touch in this starter file is the AI chatbot page. This is basically going to be similar to what we have in the AI lab report. Later in this tutorial, I might leave this as a challenge for you to implement on your own. In the file, we have the state and the default content for the AI response, and we have the code to render the content details. Finally, we touch on the notes page. This page helps the user add notes, similar to Google Notes or Apple Notes. Here you can click on the New Notes button to spin up a dialog. You can type the new title, the content, and the tags, then create the note. Next, we are going to touch on the authentication page. Let's move to the /auth root. This page is responsible for handling login and sign up. We are going to use Supabase to connect with email for authentication. We have an auth directory, and this file contains the code responsible for the authentication UI. We will throw more light on the rest of the file setup as we progress with the tutorial. We are going to start by working on the authentication page for this project. Here is the landing page for the authentication. We are going to use Supabase for handling everything that has to do with the backend and user management. Now, you might be asking, what is Supabase? Supabase is an open source Firebase alternative. It provides us with a full Postgres database, instant APIs, real-time subscriptions, and most importantly for us, a robust authentication system that handles users and login sessions without us needing to write complex backend code. Let us navigate to the Supabase website and open the dashboard. The link to this dashboard will be placed in the description. You should be on this page if you click the link. What we are going to do next is register for Supabase. Once you register and sign in, go to the All Projects dashboard. You should be able to create a new project if this is your first time signing in, or even if you have an account already, just click the New Project button. We have this dialog opened up. We enter the project name. I will choose my Vivo. Next, we create a password for the database and just click Create the New Project. Once the project setup is done, we move to the authentication icon on the sidebar, then go to the providers section. We see a list of providers here. We have email turned on by default. What we are going to look for next is the Google provider. Search for Google, click on it, and make sure the toggle is enabled. You will see that we need the client ID and the client secret from Google to make this work completely. I am going to guide you through creating a new account to get these credentials. We need to come to the Google Cloud Console dashboard. The link will be provided below on the Google Console page. We need to create a new API and service. We create a new OAuth client ID. Here, we select the application type to be a web application. We create the API. Now we can get the client ID and the client secret just by doing this. Copy the client ID, navigate back to Supabase and paste it inside the client ID field. Go back and copy the client secret. Paste that inside the secret field. Now just save everything. With that configuration done, we can go ahead and install the Supabase package in our code. Open the terminal. We type npm install at supabase/supabase-js. While that installs, let us configure our environment variables. Inside the .env file, we create a new variable called next public Supabase URL. Then we create another variable called next public Supabase anon key. To get the values for these, we visit back to the Supabase website dashboard. We will scroll all the way down to the project API section. Here, we can see the project URL. Copy that, paste it where we have the next public Supabase URL variable. Then we copy the anon public key and paste it where we have the next public Supabase anon key variable. Just like that, we have configured the authentication backend. In the next section, we are going to test out the authentication. But before we do that, we need to create a lib file to initialize the Supabase client. And in the next section, we are going to do just that. First, we import the create client function from the Supabase JavaScript library. Next, we define a constant for the Supabase URL. We pull this directly from our environment variables. We do the same for the Supabase anonymous key, pulling it from the environment variables. Now, we perform a safety check. We verify if the URL or the key is missing. If either is missing, we log a warning to the console to remind us to check the local environment file. Finally, we export the Supabase client instance. We use a ternary operator here. If both the URL and the key exist, we initialize the client with those credentials. Inside the configuration object, we access the auth settings. We set persist session to true. We enable auto refresh token, and we set detect session in URL to true. If the keys were missing, we simply return null. So right after creating that utility file for the Supabase client, we are going to create a callback route. This is going to handle the authentication response. In the app folder, inside the auth directory, we are going to create a new file called route.ts. I am going to type the code now and explain it line by line. First, we import Next response from the Next server package. We also import the type for Next request. And we import the create client function from Supabase. Just like before, we define a constant for the Supabase URL from our environment variables. And we define a constant for the Supabase anonymous key from the environment variables. Now, we export an asynchronous get function. This takes the request object as an argument inside the function. We construct a new URL object based on the incoming request URL. Then, we extract the authentication code from the search parameters. We create a conditional check here if we have the code and if both Supabase credentials exist inside this block. We initialize a local Supabase client instance using our credentials. Then we await the exchange of that auth code for a valid user session. Finally, we return a next response redirect, sending the user back to the home page. So once we are done with the root file, we are going to move back to the authentication page. Over here, we are going to set up a few things before we can try out the authentication flow from end to end. The first thing we are going to do is work on the handle email sign in. We are going to check if Supabase exists. If not, we return. But before that, make sure you import Supabase from the lib file we created. We also set an error state to hold any error that may occur. So let us create a new error state for that. Now, let us write the sign in logic. We start a try block to handle any potential errors. We define the app URL. We use the environment variable. Or fall back to the window location origin. Next, we verify the result and destructure the error property from the Supabase sign in with OAuth method. Inside this method, we specify the provider as Google. We open the options object. We set the redirect to property. Pointing it to our auth callback URL. We add query parameters. We set the access type to offline. And we set the prompt to consent. Now, if we receive an error object from that call, we throw that error immediately. We catch any errors in the catch block. We set our error state to the error message or a default failure message. And finally, we set the loading state to false. Next, we are going to work on the handle sign out function. I will type the code and explain it. First, We check if the Supabase client is missing. If it is, we simply return. Otherwise, we await the sign out method on the auth object. Now let us refresh the page and use the continue with Gmail button to see if we will be able to complete a sign in. Okay, it says access blocked. Now what we have to do is get hold of the redirect URL from Supabase and use that inside the Google console. So back to the Supabase dashboard, go to sign in and then providers. We will scroll all the way down to where we have Gmail. You can see a callback URL from OAuth. Copy that. Now move back to the Google console. Click on the API we created earlier. Add this URL to the authorized redirect URL section and save it. Now, when you move back to the page and refresh it, click on continue with Gmail. We can see we have the classic modal for Gmail Auth, and we can connect the app with any account of our choice. When we go to the user section under the Supabase dashboard, we can see the list of the user who just signed in, meaning this is working. So next, we are going to create the SQL schemes for the project. When you move to the sidebar, we can see the SQL editor. Click on that. We have this playground where you can paste code and run it. I already have an SQL code prepared. I will paste it inside this file and explain everything line by line. First, we define the lab reports table. We create it if it does not exist. We set the ID to be a UUID, defaulting to a random UUID generation, and mark it as the primary key. Next, we define the user ID. This references the auth users table, and we set it to cascade on delete. We add a column for the file name as text. We add a column for the raw text content. We add a column for structured data using JSONB. This will store metadata like the file URI. We add a column for the AI analysis text. Then we add our timestamps: uploaded at, created at, and updated at, all defaulting to the current time. Next, we create indexes for faster queries. We create an index on the user ID column, and we create an index on the uploaded at column, sorted in descending order. Now, we enable row-level security on the lab reports table to avoid conflicts. We drop any existing policies for viewing, inserting, updating, and deleting lab reports. Now we create the new policies. First, we create a policy that allows users to view their own lab reports. We check if the auth UID matches the user ID. Next, we create a policy allowing users to insert their own reports, again checking if the auth UID matches. We create a policy for updating reports using the same user ID check. And finally, a policy for deleting reports, restricted to the owner. Now, we move on to the nodes table. We create the table if it does not exist. We set the ID as a random UUID primary key. We set the user ID referencing the auth users table. We add a title column. We add a content column. We add a tags column. This is an array of text for organizing nodes. We add an encrypted Boolean flag, defaulting to false, and we add our created and updated timestamps. Just like before, we create indices, one for the user ID and one for the created at date. We enable row-level security on the nodes table. We drop any existing policies to ensure a clean slate. Then we create the specific policies. Users can view their own nodes. Users can insert their own nodes. Users can update their own nodes. And users can delete their own nodes. That completes the schema. When we run this, we might get an error saying relation nodes does not exist. So let us create a new file and run a diagnostic command. We select the result of toReg class for public.nodes. It is returning null, meaning we do not actually have the public nodes table yet. So let us go ahead and create that explicitly. I will type this out. We create the table nodes if it does not exist. We define the ID. We define the user ID reference. We add the title, the content, the tags array, the encrypted boolean, and the timestamps. Now run this query, and finally, we have a successful run. Next, we are going to create a Gemini utility file. This will be responsible for processing the PDF and communicating with the Gemini API. We will start by installing the Gemini package. You can use this command in your terminal. Now, let us import the package. We import the Google Generative AI class from the SDK. We need to navigate to the Gemini API key page to get our credentials. On the docs website, under core capabilities, we are interested in the document section. Let us search for the Gemini API key. On this page, we are going to create a new API key, copy it, and paste it inside our .env file. Now, let's write the logic. First, we define a constant for the API key, pulling it from our environment variables. We check if the API key is missing. If it is, we log a warning to the console. Then, we initialize the Gen AI client using the API key. But only if the key exists. Otherwise, we set it to null. Next, we define an interface for the lab report context. This includes the raw text string and an optional structured data object, which can contain the patient's name, the date, the test type, and an array of test results. Now, we export an asynchronous function to analyze the lab report text. This takes an input, which can be a string or the context object we just defined. First, we check if the Gen AI client is initialized. If not, we throw an error telling the user to set the API key. Next, we get the generative model. We are using Gemini 2.5 Flash. Now we need to handle both string and structured context. We declare variables for raw text and structured data. If the input is just a string, we assign it to raw text. If the input is just a string, we assign it to raw text. Otherwise, we extract the raw text and the structured data from the input object. Now, we build a context-aware prompt. We define the prompt string, telling the AI it is a clinical assistant. We inject the raw lab report text into the prompt. If we have structured data, we append that to the prompt as well. We add the test type, the date, and the patient name. Then we map through the test results, formatting them into a readable list with their status and reference ranges. Alright, we continue building the prompt with specific tasks. We ask the AI to summarize the picture, to call out abnormal values, to explain what those values indicate, to suggest follow-up questions, to use short paragraphs. We explicitly tell it not to give medical diagnoses or treatment plans, and to always remind the patient to consult a provider. We also add important formatting instructions, telling it to avoid markdown and use plain text. Finally, we call the model to generate content using this prompt. We await the response. We extract the text from the response and we return that text. We are going to reference everything we are going to do next from the Gemini doc website. Next, we are going to write a function to analyze a PDF directly from a buffer. We export this asynchronous function, accepting a PDF buffer and a file name. We check if the client is initialized, throwing an error if it is missing. We get the generative model instance. Again, using Gemini 2.5 Flash, we convert the PDF buffer to a base 64 string. Then we define the prompt. We tell the AI it is a clinical assistant helping with PDF reports. We include the file name. We list the tasks, reading the entire report, summarizing it, identifying abnormal values, grouping results into sections, and suggesting follow-up questions. We again add the disclaimer about medical advice, and we include the formatting instructions to ensure plain text output. Now, we call generate content. So inside the contents array, we define the user role, we pass the text prompt, and we pass the inline data, specifying the MIME type as application PDF. And passing our base 64 string. We await the response and return the text. Finally, we need a function to allow the user to chat with the lab report. We export an asynchronous function called chat with lab report. This takes the raw text, the previous analysis text, and the user's question. We verify the client is initialized. We also validate that the raw text is provided, throwing an error if it is empty. We get the model instance. Now we build the prompt. We tell the AI it has access to the complete raw text. We inject the raw text, truncating it if it exceeds 50,000 characters to stay within limits. If we have a previous analysis summary, we append that to the prompt as context. Then, we present the patient's question. We add critical instructions. We tell the AI to use the raw text as the primary source, to verify details, to never say it lacks access to the data, to reference specific values, to use patient-friendly language, and to avoid medical diagnoses. We add the standard formatting requirements for plain text. Finally, we ask the AI to answer the question. We await the generated content. We get the response object, and we return the final text. So next, we are going to work on the authentication flow. There is one crucial utility file we need to create, which is going to be the text formatter utility file. Now, what this code is going to do is help us format the text from the Gemini AI response. I'm going to paste the code now and explain it line by line. First, we export a function called clean markdown. This takes a text string as an argument inside the function. We check if the text is empty. If it is, we return an empty string immediately. Otherwise, we return the result of processing the text. We start with the text input. We chain a replace method to remove markdown headers using regex. This targets hash symbols at the start of lines. Next, we replace bold formatting markers, removing the double asterisks but keeping the text inside. We do the same for italic markers, removing single asterisks. Then, we remove inline code markers, stripping out the backticks. We remove strike-through syntax, getting rid of the tilde symbols. We clean up multiple spaces, replacing them with a single space. We clean up multiple new lines, ensuring we keep a maximum of 2 new lines. And finally, we call trim to remove white space from the start and end. Below that, we export a second function called format text for display. This simply calls and returns the result of our clean markdown function. So the last part of the authentication page is to complete the user profile. To do that, we need to make sure the account profile shows the email, the profile picture, and the logout button inside the component directory. There is a file called user menu. This is going to be responsible for the user profile drop-down. Right now, the logout button just sends the user to the auth page without doing anything. So over here, we are going to get rid of the default email, which says demo@example.com. Get rid of that. Also get rid of the sign out function. We will get rid of everything here and start writing from scratch. First, import Supabase from the lib file we created earlier. And import useEffect from React inside the component. We are going to create state for the user. Initialize it with a type of any and set the default value to null. Also create a loading state and default this to true. Then we have a useEffect hook. This will check if there is no Supabase client initiated. If that is the case, we set loading to false and return. Now let us get the initial user inside the useEffect. We call the getUser method on the Supabase Auth object. In the promise, we destructure the data and error. We check if there is no error and if the data contains a user. If so, we update our user state with that data. Then we set loading to false. Next, we listen for auth changes. We destructure the subscription from the onAuth state change method. Inside the callback, we set the user state to the current session user, or null if it does not exist. If there is no user session, we use the router to push the user back to the auth page. Finally, we return a cleanup function, and inside that cleanup, we unsubscribe from the listener. We ensure this effect runs when the router changes. Next, we will write the handle sign out function. We define it as an asynchronous function. First, we check if the Supabase client is missing. If so, we return. Then we await the sign out method on the auth object. And finally, we redirect the user to the auth page. Now let us handle the loading state UI. We check if the loading state is true. If it is, we return a button component. We set the variant to ghost, the size to small, and disable it inside. We simply render the text loading. Now, we handle the case where no user is logged in. We check if the user variable is null. If it is, we return a button component. We set the variant to outline and the size to small. On click, we trigger the router to push to the auth page. Inside the button, we render the logout icon and we add the text sign in. If we do have a user, we need to prepare the details. We define a constant for the user email, falling back to the string user if it is missing. Then we generate the initials. We take the user email and split it at the @ symbol. We take the first part and split it by dots. We map over those parts to get the first letter of each. We join them together. We convert them to uppercase, and we slice the string to ensure we only get the first 2 characters. So after you are done writing the code for this component, when we scroll to the return statement, there is one piece of code that is missing. We need to add the avatar image. This will contain the icon of the logged in user. So right after the main avatar component, we are going to import and use the avatar image component. This component generates an avatar image for the user. We give it a source name. We grab the source from the user metadata avatar URL and we add the alt text. Now everything is fine, so we can actually log in, connect our account, and see if it works. And there you go, we have our profile picture, our email account, and we have the logout function working. Everything is on track. So next, we are going to work on the upload report function. Right now, when we click on this button, it just shows the modal. We are unable to process a PDF yet. That is what we are going to work on next. On the lab reports page, we are going to work on the lab report logic. So on this lab reports page, we have all these imports. We are going to get rid of the dummy data, which contains static information about the analysis. Once we get rid of that data, we will replace the space with an empty array so that there will be no errors in the code. We are going to add a loading state, which by default is going to be true. And we are going to create a use effect hook. We are also going to create a function to fetch the lab report called the fetch lab report function. First, we define the asynchronous function called fetch lab reports. We check if the Supabase client is missing. If it is, we turn off loading and return. We start a try block to handle the fetch, and we set loading to true immediately. We fetch the current user from the Supabase Auth method. We check if the user is missing. If they are, we log a message, set loading to false, and return. If we have a user, we log that we are fetching reports for their ID. Next, we need the session token for row level security. We get the session from Supabase Auth. We initialize a headers object. If we have an access token in the session, we assign it to the authorization header using the bearer scheme. Now, we await the fetch call to our API endpoint, passing the user ID in the query string and including our headers. We will be creating this route soon, but for now, make sure you have this code here. We await the JSON parsing of the response. We log the fetched data to the console. Now we check if the data success flag is true. If it is, we log how many reports we found, and we update the lab report state with the data, or an empty array if it is null. If the request failed, we log the error message. We add a catch block to handle any network errors and log them. Finally, we ensure the loading state is set to false regardless of the outcome. So next, we are going to create a use effect to trigger this fetch. We do not have use effect imported yet, so we are going to import it from React app there. Next, let us make the lab report array an empty array so the calculate statistics logic works. First, we calculate the total reports based on the length of the array. Next, we calculate normal reports. We filter the lab reports array. Inside the filter, we grab the test results from the structured data, defaulting to an empty array. We return true if every single test in that array has a status of normal or has no status at all. Then we get the length of that filtered list. For abnormal reports, we simply subtract the normal reports from the total. For critical reports, we filter the list again. We grab the test results. And we return true if some of the tests have a status equal to critical. And we get the length of that result. So now on the website, when we click on the Upload Report button, we are unable to select any PDF file because the logic is missing. The actual upload is supposed to happen inside the lab report upload file, inside the component directory. So inside here, we have these use state variables. We have a state for open to control the modal. We have a state for the file to store the selected PDF. And we have a state for error handling. We also have the handle select function, which processes the file input. And we have the handle upload function, which we are going to implement inside this component because what we have here currently is just dummy code before we start writing the upload function. Let us add one more state. We are going to add an uploading state to keep track of the process. Now, back to the handle upload function. First, we check if no file is selected. If so, we set an error message asking to select a file and return. If we have a file, we set uploading to true and clear any previous errors. We start a try block. First, we get the current user data from Supabase. We check if there was an error retrieving the user. If so, we log it and throw a new error message. We also check if the user data itself is null. If so, we throw an error asking them to sign in. Now, we try to get the session. We initialize a session variable to null. We call getSession from Supabase. We check for any errors and log them. If we have session data, we assign it to our variable. If not, we try to refresh the session. We call refreshSession. And assign the result to our variable. We catch any errors during the refresh. Now, if we still do not have a session or an access token, we set an error message explaining they need to sign in. We set a timeout to redirect them to the Auth page after 2 seconds. We turn off the uploading state and return. If we are good, we assign the user data to a constant. Now we create a form data object. We append the file itself, we append the file name, and we append the user ID. Finally, we await the fetch call to our upload API. We use the post method, we add the authorization header with our access token, and we pass the form data as the body. Now, before we continue with the response handling, let us go ahead and implement the route for uploading the lab report. Inside the API folder, we have the lab folder. Inside the lab folder, we are going to create an upload folder and create a root.ts file directly under that. First, we import next request and next response. We import the create client function and we import our Gemini analysis helper. We define the Supabase URL and anon key from our environment variables. We export the asynchronous post function. We start a try block. We check if the environment variables are missing. If so, we return a 500 error. Next, we get the auth token from the header. We strip out the bearer prefix to get the clean token. If the token is missing, we return a 401 unauthorized response. Now, we create a Supabase client specifically for this request. We configure the auth settings to disable auto refresh and persistence, and we inject the user's access token into the global headers. We explicitly set the session on the client to enable row level security. Now we verify the user with that client. If there is an error or no user, we return an invalid authentication response. Next, we pass the form data from the request. We extract the file, we extract the file name, and we extract the user ID. We check if the provided user ID matches the authenticated user. If not, we return a forbidden error. We check if the user ID is missing entirely. We check if the file is missing. And we check if the file type is not a PDF, returning a 400 error if it is invalid. Now, we convert the file to an array buffer, and then convert that into a node buffer. We prepare a variable for the AI analysis. We run a try block to call our Gemini function with the buffer and file name. we log the length of the generated analysis. We catch any errors from the AI but allow the process to continue. Now, we store the data in Supabase. We insert a new row into the lab reports table. We pass the user ID, the file name, a placeholder for raw text, null for structured data, the AI analysis, and the timestamp. We select the inserted row and get the single results. If there is a database error, we log it and return a 500 error. If successful, we return a JSON response containing the success flag and the lab report details. We catch any top-level errors, log them, and return a 500 response. Now back to the lab report upload file. On the front end, we are continuing the code where we left off. We pass the JSON data from the response. We check if the response was not okay. If so, we throw an error using the message from the server. We also check if the data success flag is false and throw an error if needed. If we pass those checks, it is a success. We log the successful upload. We clear the file state. We clear the error state. We set a temporary success message saying it is refreshing. We set a timeout. Inside this timeout, we close the modal, clear the message, and reset the file input value. If we have an on-upload success prop provided, we call it immediately to refresh the list. We catch any errors and set the error message state. And finally, we set uploading to false. So, fingers crossed, let us test the application. On the website, when we click on the Upload Report button and select a file, we see an error saying missing Supabase environment variables. This looks like a typo in our environment setup. Back to the root file. When we check the environment variables we use there, we have next public Supabase anon key and next public Supabase URL. So to make sure everything is typed correctly, we copy the variable name from the file and paste it into our environment file to make sure we are on the same page. Now, let us try and upload a new lab report again. We can see we have an upload successful message, which is this 200 response in the terminal. When we check the Supabase website and go to database, then tables, and click on lab reports, we can see the recently uploaded lab report file, which means the code is working perfectly fine. So currently, we are unable to view the lab reports. This means we have to work on fetching them from the backend when we inspect the page and open the browser console. Let me just move the console tab to the bottom for better visibility. When we check the network results from the server, we see that we are getting a 404 not found error. This confirms that the API endpoint does not exist yet. We need to create it. Back in our fetch function, we defined a response variable that tries to hit the API root using the user ID. But since that root does not exist, we are going to create it now inside the API folder, under the lab folder, and inside the reports folder. create a new file called root.ts. Let us start writing the code to fetch the data from Supabase. First, we import next request and next response from the next server package. And we import the create client function from Supabase. Next, we define a constant for the Supabase URL using our environment variable. We also define a constant for the Supabase anonymous key using its environment variable. Now, we export an asynchronous get function that accepts the request object. We start a try block to handle potential errors. We check if either the Supabase URL or the key is missing. If so, we return a JSON response with an error message and a 500 status code. Next, we extract the authorization token from the request headers. We clean the token by removing the bearer prefix if it exists. Now we initialize the Supabase client. We configure the auth options to disable auto refresh and session persistence. Since this is a server-side request, we use a spread operator here. If an access token exists, we inject it into the global headers for the client. Next, we verify if the access token was provided. If it was, we explicitly set the session on the auth object to enable row-level security. Then, we retrieve the user ID from the URL search parameters. We check if the user ID is missing. If it is, we return a 400 error stating that the user ID is required. Now we verify the user, but only if an access token was provided. We call the getUser method on the Supabase auth object. We check if there was an authentication error or if the user object is null. If so, we return a 401 status for invalid authentication. We also perform a security check, ensuring the requested user ID matches the authenticated user's ID. If they do not match, we return a 403 forbidden error. Now for the database query, we await the data from the lab reports table. We select all columns. We filter the records where the user ID matches our variable, and we order the results by the uploaded at timestamp in descending order. We check if the database returned an error. If so, we log the error to the console, and we return a 500 error response with the details. If everything is successful, we return a JSON response containing a success flag and the array of lab reports. Finally, we catch any unexpected errors in the main try block. We log the fetch error to the console, and we return a 500 response with the error message. The delete request will not be worked on in this tutorial. It is going to be a challenge for you guys to implement on your own. Since we are done implementing the get lab report route, let us refresh, move to the home page and refresh the page here. Let us see if we are able to get something from the backend. and it seems we are getting something from the backend. When we check the console, we can actually see the lab report being fetched inside an object with two properties. We have the lab report array itself, and the success flag is true, meaning we are getting data from the database. Congratulations if you have made it to this part. Notice we are getting this result after uploading the lab report. This is a response from the AI analysis. Remember, we created this route inside the lib folder called the Gemini AI. And inside the lab route, we had that logic as well. The return result is being shown here as the lab report analysis, but we should be able to make a follow-up request. For instance, when I copy this lab report and paste it here, I should be able to analyze it with the AI and also get a response. But currently, it says this is a demo analysis, meaning we have to hook the analysis with the Gemini AI properly so that we are able to communicate with the service. So now to do that, back to the lab reports page, we are interested in the Gemini panel component. This is the panel responsible for the actual response, not the chat wrapper. So in the lab Gemini panel file, we are going to add some state. We create a constant for the loading state, defaulting it to false, and we create an error state, defaulting it to null. Inside the handle analysis function, we reset the error analysis to null, and we get rid of this static data so we can start implementing the actual code responsible for communicating with the Gemini AI. I will type the code now. First, we start a try block to handle the network request. We await a fetch call to the API endpoint for lab analysis. We set the method to post. We set the header's content type to application, JSON, and for the body, we stringify an object containing the input text. Next, we await the JSON parsing of the response. We check if the response was not okay or if the success flag is missing. If so, we throw a new error using the error message from the data or a default failure message. If successful, we update the analysis state with the returned data. We add a catch block to handle any exceptions. We set the error state to the message provided or a generic fallback. Finally, we use a finally block. Inside here, we ensure the loading state is set to false regardless of the outcome. So after creating this function here, we need to create a route to actually do the analysis. To do that, we are going to create a new root file inside the lab folder. Under the analyze folder, create a file called root.ts inside this folder. We are going to write the code to perform the analysis. First, we import next request and next response from the server package. And we import our helper function called analyze lab report text from the Gemini library. We export an asynchronous post function that takes the request. we start a try block. We extract the text property from the JSON body of the request. We perform validation. We check if text is missing or if it is not a string. If so, we return a 400 error for invalid input. If valid, we await the result from our analyze lab report test function. Then, we return a JSON response with success set to true and the analysis data. We catch any errors that occur during the process. We log the error to the console for debugging, and we return a 500 error response, including the error details. So now it is actually time to test and see if what we did is working. When we click on the Analyze with AI button, we can see we get a 200 response from the terminal, and we also get a real response in the test input div right under the button. But we actually need to enhance the user experience. There should be a loading indicator to tell the user that processing is happening. So back to the lab Gemini panel. We are going to make sure the button text is rendered conditionally. We check the loading state. If it is loading, we write analyzing. Else, we write analyze with AI. Now everything is working perfectly. So let us move on to the notes section. We want the user to be able to add notes inside the application. Right now, when we move to the sidebar, we have AI chatbots. By the way, I am not going to work on that because it is going to be similar to the AI we had in the lab report. So I will let you try that and improve your skills, because the learning actually happens when you build things on your own. So let us move to the notes section. Here we are going to create our own notes app for the user to be able to add notes. This helps them keep track of their health reports. Back to the directory. Inside the notes folder, open the page.tsx file. We are going to get rid of the dummy data and replace it with an empty array. And also, we are going to add a couple of states. I will type the state definitions now. First, we define a state for the user email and initialize it to null. Next, we define a loading state and set the default to true. We define a saving state and set the default to false. And we define a deleting state, which holds the ID of the note being deleted or null. So we are going to create a function called handle create note. We likely already have the function signature, but let us implement the logic. First, we check if the note title is empty or just white space. If it is, we alert the user to enter a title and return. Next, we check if the Supabase client is configured. If not, we alert the user that the environment variables are missing and return. We set the saving state to true to indicate the process has started. We start a try block. So we await the current user data from Supabase Auth. We check if there was an error fetching the user. If so, we log the error and throw a new error message describing the authentication failure. We extract the user object from the data. we check if the user is null. If so, we alert the user to sign in and return. Now, we process the tags. We take the tags string, split it by commas, trim white space from each tag, and filter out empty values. Now we perform the database insertion. We await the insert command on the notes table. We pass an object containing the user ID, the title, the content, and the tags array if it is not empty. We chain a select method to retrieve the ID, title, content, created at date, and tags, and we request a single row response. We check if the database returned an error. If so, we log it and throw a detailed error message asking to check the table and policies. We also check if no data was returned at all. If so, we throw an error stating no data came back from Supabase. Now, we construct our local note object from the returned data. We map the ID, the title, and the content. We format the date by slicing the first 10 characters of the created at timestamp. We handle the tags, ensuring it is always an array, even if the database returns null or a single string. And we set encrypted to true. Now, we update the notes state by adding this new note to the top of the previous list. We reset the new note form state to empty strings. We set its dialog open to false to close the modal. We log a success message to the console. We catch any errors that occurred in the process. We log the failure and alert the user with the error message. Finally, we set the saving state back to false. Now we are done with creating the note function. Let us work on loading the notes from Supabase. We are going to create a useEffect hook to load the data. We call useEffect and define an asynchronous function called load inside it. First, we check if the Supabase client is missing. If it is, we warn the console, turn off loading, and return. We start a try block. We fetch the current user details from authentication. If there is an error, we log it, turn off loading, and return. We extract the user object and update our user email state. If the user is not found, we log that, turn off loading, and return. Now, we perform the query. We await the select call on the notes table. We request the ID, title, content, created at, and tags. We filter records where the user ID matches the logged in user, and we order the results by creation date in descending order. We check if there was a database error. We log the error. We specifically check if the error code indicates the table does not exist, and warn the user to run the SQL schema. If there is no error, we log the number of nodes loaded. Then we map the raw data to our typed node structure. We map the ID, title, content, and format the date. We handle the tags logic again, passing strings into arrays if necessary, and set encrypted to true. Then we update the node state with this mapped data. We catch any unexpected errors during the load. And finally, we set loading to false. Outside the function definition, we call the load function, and we pass an empty dependency array to run this only once on mount. So now let us test the node feature together. Before we do that, let us go to the inspection page and see what you'll be getting in the console after you create the node. I will click on the Add Note button. Add a title to be first note, content to be first content, and tag to be tags. I will create the note. And inside the console, you can see we have a message here saying notes created successfully, meaning we have the notes created successfully. Now we move to the Supabase dashboard, click on database, then tables, and click on notes. you will see that the nodes that we just added are being shown here. So everything is working fine. In this section, we are going to work on the part of the application where a user connects an email using Scalekit connectors. This will allow us to send lab reports to the users after analysis. When we click on the Connect Gmail button and select Connect Gmail, we should be able to connect our account using Scalekit. That is what we are going to implement next. Now, what is Scalekit? Think of Scalekit as the infrastructure for our B2B integrations. Instead of building the entire OAuth flow ourselves and maintaining fragile API connections, Scalekit handles the heavy lifting of authentication and enterprise identity for us. Let's get started. After signing up at scalekit.com, click on the Start for Free button. This takes you to the Sign In page. If you do not have an account, I highly recommend you sign up. If you do, just log in to access the dashboard. On this dashboard, we have a lot of features. Click on Organization. You can see I have one organization created. You can create your own here. We also have a user from a previous application test and an MCP server. For this tutorial, we are interested in setting up connectors using agent actions. So come to the Connection tab. Here we have the Google Calendar option. We have Gmail, and we can add our own connections. We are interested in connecting Gmail. Before we do that, let us move over to the NPM website and search for Scalekit SDK node. We need to download the SDK using the command shown here. Copy the npm install command, paste it inside your terminal to get that installed. Now start writing the code for Scalekit. On the Agent Action tab in the dashboard, we are going to create a new Gmail action. Here we will use our own credentials. You can see we have the redirect URL, the client ID, and the client secret. Grab the client credentials that we created using Google OAuth. If you already set that up in Supabase, you can go ahead and copy those. Paste them inside the client ID field and also the client secret field. Alright, so after you are done with that, change the access type to online. Then just save it. Back to our code base. We create a new file inside the lib folder called scalekitconnectors.ts. I am going to type the code now, and I will explain every line as we go. First, we import the Scalekit client from the Scalekit SDK node package. Next, we define a constant for our environment URL. We assign this to the process environment variable or use the default development URL if that is missing. Then we define a constant for the client ID, pulling it from our environment variables. We do the same for the client secret, pulling that from the environment variables as well. Now, we initialize a variable called client. We set its type to Scalekit client or null and initialize it as null. Next, we write a function called getClient that returns a Scalekit client. Inside this function, we start an if statement to check if the client does not exist yet. Inside that check, we add another validation. We check if the client ID or the client secret is missing. So if either is missing, we throw a new error stating that these variables must be set. If the credentials exist, we instantiate the client variable as a new Scalekit client, passing in the URL, the ID, and the secret. Finally, outside the if statement, we return the client. Next, we export a function to get the authorization URL for a connector. This function takes an options object. This object includes the connection ID, the redirect URI, an optional user ID, and an optional state string. Inside the function, we create a constant called SC. And call our getClient helper to assign it. Then we return the result of calling the getAuthorizationURL URL method on our client. We pass in the redirect URI as the first argument. For the second argument, we pass an object containing the connection ID. We use a spread operator to conditionally add the login hint if the user ID is provided. We also use a spread operator to conditionally add the state if it is provided. Moving on, we export an asynchronous function to handle the connector OAuth callback. This function accepts the code as a string and the redirect URI as a string. Inside, we once again get our client instance. We create a result variable and await the authenticate with code method, passing in the code and the redirect URI. Then we return an object. Inside this object, we have a user property. This user property contains an ID, which we map from the result user ID. It also contains the email from the result user email, and it contains the name from the result user name. Outside the user object, we also map the organization ID from the result. Finally, we export a constant called connector IDs. Inside this object, we define Gmail. We set this to the environment variable for the connector ID or default it to the string Gmail. That concludes the code. Make sure you have all the environment variables set up for this project before we try the Scalekit Connect. Now is the moment of truth. When I click on the Connect Gmail button and click on Connect Gmail, I should see the classic Google Auth screen to connect a Gmail account. We are going to host the app on Vercel. Visit vercel.com, create an account if you do not have one. Now we will click on the Add New button and select Project. We need to import the Vivo project. This means you have to push your repository to GitHub first before you will be able to host this. I think there is also a public repo hosting option or something of that sort where you can host without creating a Vercel account. You can search for that option if you prefer. Next, we are going to add the environment variables. Copy them from the .env file we have in the code repository and paste them into the Vercel configuration. Now, deploy the project. So now we have a build error. It is complaining about variables which were defined but never used. So we are going to go back to the code and update the next config file to handle this. We will use Cursor AI to fix this quickly. Let us open the chat interface using Command I on Mac or Control I on Windows. Now drag and drop the next config file into the chat and add the prompt. Ignore build errors from both TypeScript and ESLint. Now it is done. Let us accept the changes and push the code to GitHub to automatically restart the build on Vercel. We are also getting another error again. This time it is about some update in the Next.js version. So let us copy the error and paste it inside the chat in Cursor AI and wait for the solution. So it turns out we should just update the Next.js and ESLint config versions to be 1 point higher. For those who do not know what Cursor AI is, it is an AI-powered code editor built on top of VS Code. It understands your entire code base and helps you write, refactor, and fix code much faster than traditional autocomplete. Let us push this code once again and see what we get. Finally, we have a successful build. When we click on the link, we can see the authentication page from the project. Congratulations if you have made it this far. That will be it for this tutorial. Subscribe, like, and share this video. See you in the next one.